Hello, I'm Giselle Soto, and today I will be making my concentration series of solutions out of Kool-Aid. On the back of the Kool-Aid packet that I'm using, it says that 0.5 grams are used in each 1/8 serving size. So that means that there's 8 servings, meaning that there are 4 total grams in the package that I have used. In order to find the number of moles in my mother solution, I took the 4 grams from the initial package and then I divided it by the molar mass. In order to find the molar mass, I took sucrose, which we're assuming Kool-Aid is made up of most of, and then I found the masses of each element and times it by the amount that there was. So for carbon there was 12, hydrogen there was 22, and oxygen there was 11. So the total of moles that I found for my initial solution was 0.0117. I then added 200 milliliters of water to the solid. In order to create my second solution, I took out 15 milliliters of the mother solution and added it to an identical glass container, and then I added up to 200 milliliters of the volume to equal the 200 milliliters of the mother solution. I continued this for my next 3 solutions in order to create my solutions of different concentrations. You will begin to see that as the solutions continue, the dilutions increase, meaning that the amount of moles in each solution decreases. By the time I reach the 5th solution, it looks like the concentration is nothing and it's basically just water, which is exactly what we're aiming for in order to reach the parts per million concentration. Okay, so the calculations behind my solutions was through finding the molarity of the initial solution, which is the mother solution. So I took 0.0117 and plugged it into the equation, and 200 milliliters converts to 0.2 liters. So the molarity would be 0.059. Continuing from there, to find the second solution molarity, I plugged it into the equation of the dilution formula. So I did 0.059 of the initial molarity of the mother solution times the 15 milliliters that I took out of it, which equals the total 200 milliliters of the second solution times the unknown. I then solved for the unknown, which was the molarity of the second solution, and then I found that the molarity was 0.044. Then, in order to find the third molarity of the third solution, I took the molarity of the second solution because we're treating it as if it was the mother solution, and then I plugged it into the dilution equation, which gets us the molarity of the third solution. I continued this method throughout the 5th solution, and I found that I did in fact reach the parts per million for my final solution, which I'm very proud to state. So those are all the calculations explained on how I found the concentration and molarity of each solution. As you can see, this is my concentration solutions, and they go from darker to lighter as each concentration decreased because we continue to take from the previous solution and dilute it even more. This concludes my Kitchen Lab 5 video, and I'm proud to say that I did reach the challenge of reaching the parts per million concentration by the 5th solution. Thank you for taking the time and watching my Kitchen Lab video 5 on how I made my concentration series of solutions.